put the, maybe this might work better. That this requires, we have cooling water over here, and this is just for recirculation, doesn't have to be cooled. It's half tap, half DI water. The gases, argon, 4 nines purity is sufficient. Pressure at 80 psi. Nitrogen, 4 nines again, 20 psi. And this is used for elements that are going to be analyzed with wavelengths below 190. You need to purge this at least 1 day before you're analyzing those wavelengths. Exhaust should be 100 CFM. I think it's a little low. One way to know if your exhaust is sufficient, if you can leave your hand on this Faraday cage and it's just warm, then the exhaust is good. If you can't leave your hand on here, it's too hot, then you're not pulling enough out. The system consists of 3 basic areas. You have your sample introduction, which is down here. I'm going to take this all out so you can see it better. You have your plasma generation, which consists of electronics down below, which create the argon plasma. And then underneath here you have your light analysis, which consists of a monochromator, which separates the white plasma light into all your wavelengths that you're going to look at for each individual element. So to pull out the torch, because you're going to have to do maintenance on that occasionally, what you need to do is first, can you get all this in there? Okay. This just slides out, just a piece of welding glass so you can see the plasma. This optical channel, which is where the light enters your optical box, tube will pull back somewhat and then allow you to unscrew the front part. There are 2 lenses in the optical channel. One is in this first part that I'm taking out. The other one is in the section that this tube connects to on the inside. So there's one lens right there. This just unscrews. The other one is the same way. They have a flat side and a convex side. They're cleaned with acetone only and a Kim wipe. I cleaned them yesterday. Then the Faraday cage will slide up to these notches, and then you could just take it off like this and just rest it up here. Your torch comes out by, these are all quick gas connects. You push on the green ring and you pull on the hose at the same time and it comes out. When you're putting it back in, all you have to do is push it in. It should not come out unless you push on the green ring. Now, let me just see. Spray chamber, you unclamp this, and then there's a lock nut on the device that holds the spray chamber. It's over on the left side. If you loosen it, then that allows this clamp to come down, and then your spray chamber comes out like this. Your torch, you loosen this knob so you can swing that over and your torch comes out like that. So I will take this apart to show you the components. This is called the outer quartz tube. These tubes all slide out. This is the injector, which is where your sample will come into the plasma. If you can hold the torch by the injector and the injector doesn't come out, then your Teflon piece that this plugs into, you know that that's a nice tight fit, and that's what you always want to have. This is called the sheath gas. This also just pulls out like that, and then your torch comes out like this. This will also come out. If you have a loose fit, what you can do is put a little Teflon tape right around the base here, not in, you don't want to obstruct the hole obviously, and then just plug it back in. This screw on the bottom is your reference height screw, which sits on this shelf right here. And what that does is it puts the torch in the right perspective inside the load coil. The torch has 7 O-rings, 2 for each one of these tubes, 2 for this guy, and 1 for the bottom of the injector. And then there's another one right in here that separates the 2 halves. This doesn't come apart. So you basically have 4 O-rings through here, which a dental pick is good to have to pluck them out because they're hard to get back in and pull out sometimes. You want to make sure that when you put this back together that this screw is opposite your gas fittings. So this way it'll, sit on that ledge that I showed you. This is called a Teflon insert. Your injector will plug into this like that. So that should have a nice snug fit. Otherwise, if you get air coming in through here, your results will be all to hell. This injector, if you need, this Teflon insert, if you need to replace it, what I do is I take like a hex key, I put it through this end and I smack it because it's in there pretty tight. To put a new one back in, you just push it, you put it in there, and then I normally just push against something until it stops. You'll feel it stop. This normally has a small O-ring around it to hold this. This is called a centering ring, and this just basically, it should come off, but this just keeps the injector centered inside the inner quartz tube, like this. Actually, that ends like that. That's how that goes. It basically just goes like that. This will fit in first. Inner quartz. Now if your Teflon insert down here is seated all the way in and the injector is all the way in, then what you end up with is your injector should be just a hair below the inner quartz tube, which it is. The outer quartz does not go in all the way, so you'll still have a little bit of the frosted area sticking up. Okay, so next would be, oh, did this wrong. This has to go on here first. This has a line drawn on it, so I basically just put it up to the line, and then you can readjust it once it's put back in. This should fit up and snug, and then what I do is I have the screw, the back screw rest on this shelf. Like that. I clamp it. And then I'll tighten the bottom piece on here. Torch height inside the coil. The inner quartz tube should be like 1 millimeter below the bottom coil. That's how you know your height is right in the coil. Coil spacing should be 15 millimeters from the center of the bottom to the center of the top, plus or minus a half a millimeter. Just in case if you change the coil, then you know exactly how that should be. Another thing to check is you want to make sure that none of the quartz tube is touching the coil. So I take like a little cable tie, go all the way around, make sure that it's free. Nothing can touch that. Okay, spray chamber. Now, this comes off, but it's not wanting to come off, so I'm not going to force it. I might crack it. There's an O-ring in here. There's an O-ring here for the nebulizer where that plugs in. Your drain should come off, but it's not coming off, so I'm not going to force that either. But to get that off, you take this clamp off, and then it should separate. There's just frosted glass. You always have to have water in the drain. You need the back pressure on the spray chamber so your sample will go up. If there's no water in here, your sample is just going to go right out the bucket and you won't see anything. So we push this down, put the spray chamber in, and then it should have like an angle to it so gravity feeds out. And the same with the drain tube. You don't want it to be sagging to create another dip so you have a second back pressure, because that'll cause all kinds of problems. So like if that bucket fills up past the tube, then it's going to cause another back pressure. You don't want that. All right, so put the clamp on. This is your nebulizer. Your sample, your liquid will come in here from the pump. Your argon gas will come in here. The two mix and you get a mist which fills the entire spray chamber. If you're going to run any samples with high salt, you want to use the humidifier because it'll clog up this type of nebulizer. It's the glass concentric. It'll clog up the tip with salt if your sample is high salt. So what we need to do is you take this hose off, you feed it into the top of the humidifier. If it reaches over, it should reach over there. Anyway, it goes in this fitting here. And then this is your output. Then your output will plug back into the neb. So what you're doing is you're humidifying the nebulizer gas so that it'll prevent clogging of salt on the tip. Once it clogs, it's shot. Put about this much DI water only in this. If you're not running any high salt, you don't need to worry about that. If you are using the humidifier on the startup procedure, once you purge the torch with argon through these gases here, you need to turn your nebulizer off and discharge the humidifier and then close it. And then once the plasma is lit, you can turn the nebulizer back on. Okay. All of the gas going into the torch is argon, nothing but argon. The nitrogen is just used for your optical purge. So our main carrier gas is plasma 1, P1. That should be 12 liters a minute. That's nominal setting for aqueous. This is coming out of here. Plugs into the top. Where was that diagram? Oh, there wasn't a diagram on here. But anyway, green corresponds to green. Green is on the top. This is your igniter wire. This sends an electric spark, follows the argon stream, and ionizes the argon gas. The coil's purpose is just to heat that gas up, 10,000 Kelvin. You don't want to get too close to that. Your next one is your auxiliary gas, which is only used when you're running organic samples, xylene or kerosene matrix. You need to, what that's going to do is when you have an organic plasma, the plasma is going to want to sit on top of the inner quartz tube, and the auxiliary just pushes the plasma up. Otherwise, it'll carbon up that whole inner quartz tube. You won't see anything. Your red goes down here. This is called a sheath gas. What this does is it mixes with your nebulizer carrier gas and just mixes together. It's just a gas that's always used for I don't know what the main purpose of it was, but okay, so 12. Your G1 should be 0.2. It's a little high. The adjustments are all preset with electro valves, which are all labeled right inside here. So I'm gonna just lower that G1 gas a little bit. Use the center of the ball. So what you want to do then first, before you start, turn all the gas. We're only using these 3 gases here: your plasma gas, your sheath gas, your nebulizer gas. If you were to run an organic sample, you're going to use P2 also. What that does is it gives you 16 liters, and you also run your auxiliary. I don't know where that's set at. 0.6, that's about right. So, but we're not using those 2. I'll show you how to adjust the nebulizer pressure. This is the flow meter for the neb. It's left all the way open, and the flow is established by the nebulizer. The pressure for the nebulizer comes through a regulator. Your other gases are regulated by the pressure regulator on the tank. So your neb pressure, which is here, is cut down some from your 90 pounds that are coming in. So it's roughly about 3 bar, which comes out to be about 45 psi, I guess. So we're going to put in just some water first. Your pump tubing, at the end of the day, just make sure you unclamp it. If it's clamped overnight, it's shot. And this nebulizer will suck in on its own. You'll see the, where is it? It is on, right? Yeah, right there. Right there, it's coming up. So, yeah, even without the pump, that nebulizer will have Venturi effect on the very tip, so it'll just draw it in on its own. But we use this so that it's got a steady, steady flow. Wrong way. If you want to speed it up, you just keep your finger on that, and then you'll see a mist in the spray chamber now. All right, so put this back on. If you've taken the optical channel back, you want to put it forward as close as you can get it to the plasma without it touching that or the quartz tube or the coil, because if you're looking for elements in the UV and you've purged with nitrogen, you need to have that nitrogen come and fill the entire optical path. So this has to come all the way out to the plasma. If you have air between the plasma and the optical channel, it's going to absorb those UV lines, so you're not going to see anything. Okay, so to start, we turn the neb off. Once that pressure's dropped off, and if you're using the humidifier, it's going to take longer for it to drop off. That's why you have to discharge it manually. So once that's dropped off, we click on start. You let that sit a couple of seconds. As far as power setting, you always use power 1. That should be equal to 1,000 watts. That's nominal for aqueous. And then that should be up. One way to tell if you've changed your nebulizer or something, you want to make sure that your neb pressure is still correct if you change something. So if you put in 1,000 ppm of yttrium, there's certain colors that come out in the plasma, and that'll tell you how you can adjust your pressure. Okay, so what we're looking for is, if you see what we call it's the tip of a bullet, the orange part below the blue, that should come up 1 to 2 millimeters above your top coil. Most of your light emission takes place theoretically in the middle of the blue zone, which is what this should be looking at. If I bring this down, you'll see it come down. So that adjusts that nebulizer pressure directly. So right now is about where I had it. It's about 2 millimeters above the top coil. Okay. All right. So, I don't know if you can get inside here or if you need to get inside, but I can like point things out just real quick. So down in here, your light comes in the optical path into this. This is a slit assembly. There are 2 slits in here that are controlled by the software, 10 and 15 microns. The light enters through the slit. It comes down this end to a mirror, which then bounces the light back to your holographic grating, which is here. The grating's job is to split the white light from the plasma into each individual wavelength. Once it does that, it sends that light to a second mirror down this end, and then back out another exit slit assembly, which is 15 and 80 microns, to this photomultiplier tube, which converts the light into an electrical signal, which goes out to the computer. Some of the boards here, I'll tell you what they do. This is a power supply for the boards that are plugged in here. This board, the MDRMS, its job is to move the grating. Interface board is what communicates to the computer. The high voltage is what adjusts the high voltage on the photomultiplier tube, and that's adjusted automatically with the software. The acquisition board takes the electrical signal from the photomultiplier tube and converts it to a frequency. That goes out to the computer also. This PIO board just controls your slits. This is a climate control. I only leave on the one for the monochromator. If you have large temperature swings in the room, it's going to affect your results. The optics will shift just a little bit. So they have a heater underneath the optical box to keep the optics at a temperature like 5 degrees higher than room temperature, like 30 Celsius. Okay, everybody all right so far? Getting all this? All right, so we can go over to the software. Okay, so to open the software, we double click on ICP. You only have one version on here, it's 5.2. The default for the main user would be 3 and 3. This just tells you what version you have. This will, well, we don't care about that. This tells you different colors you can set for the menus. But there was a place here for, that's not what I want. Maybe it's, this is a lab book. If you want to enter when certain things were done, you can enter it in here. Your management icon is for the databases of, well, you don't have an auto sampler, but these are auto sampler trays and racks. This is a if you want to assign someone else permission to use this, but you don't want them to have access to changing a method, you can assign them a lower level. 3 allows you to do whatever you want. What else we got here? Some of these are kind of redundant, and I don't know what all of these are used for, but mini calibration, it's a database of a calibration table if you make one up. control tables. That's for, I think that's used like for in-process controls. This is a library of all your wavelengths. The ones that have an offset, this is supposed to be wavelength practical, which means that I've used this aluminum line and it found it at, this is the theoretical and this is where it actually found it. So if for some reason you need to take the offset out, then it'll go back to and look for that wavelength at the theoretical position. This intensity column will tell you the detection limits, the ones with the, where's barium 455? That's not here. Some of these are not in here. I don't know why but if you click on this and make them all numerical, then they'll come up. But I wanted to see what barium 455 was at. So you can see how much intensity. So this is the most sensitive barium line. More numbers, more intensity counts. If you need to add a wavelength that's not in here, you can go here, add lines, and then just say, it might not, the line might not be in there, but this will pull up all the aluminum lines. So say I wanted to make one that wasn't here, click on new line, just put in your symbol, and then you can put in whatever. Invalid input value. Maybe I need 3 letters there. Invalid input. Use escape key to abandon changes. Maybe I have to have 3 numbers? That's what I need, 3 numbers. So they won't have, like all the wavelengths won't actually be in here, and that's how you can create one that you might want to use. Say it's, if you're looking at a percentage of an element and most of the lines are sensitive and you find that you've put that in your method but it's still overranging, so you want to pick out a wavelength that's not really a sensitive wavelength. That's how you could, you know, make a new line. Standard database. Again, I've never used any of these, so I don't know if you will have a use for them or not. This is all the methods that have been created. I made these 2, and these 2 here are just default. They come out in the software already. Some elements, I mean, some methods are already in here. I mean, not methods, matrices. If you're running a matrix, say of cobalt, it'll put in here what wavelengths it thinks you might want to look at if you're running a cobalt matrix, which really isn't the case. I mean, you're going to have your specific stuff you want to look at anyway. So I don't know how much use that is, but okay, here is where we do what's called a zero order and a reference check. And you're going to do this often. So the first thing, if for some reason the power's been off, you want to reestablish communication. So you click on that. It'll identify the electronic boards that are in that rack. It'll tell you all the boards and their addresses. So you should have 4 boards: your high voltage, your PIO, your diff is actually called acquisition in there, and the MDRMS is the one that moves the grading. First thing we do is a zero order, and what that does is it moves the grading so it's parallel with the mirrors and it doesn't split up any of the white light. So it's looking at all the white light. That's the initial starting point, and you only need to do that if you lose the reference. The reference wavelength that we're using is a carbon line, and the reference wavelength has to be something that's always in the plasma, either argon. If you're purging with nitrogen all the time, you can use that, or carbon. And I don't know why carbon is there. It's not combusting, so it's just there. I don't know. Maybe from the water. I don't know. So it's going to do 4 scans. The first scan will be in steps of 500 motor steps. The second one will be in 50, then 20, then 1. So it gets more precise, and as it gets more precise, the voltage is cut down for each scan because otherwise it'll overrange. So this only needs to be done if the power has been off, if you've lost communication, or if you've lost the reference. So it's going to begin at, these are motor steps, these are intensities, and you'll see that the first scan overranged. The most important is you don't want the last scan to overrange because this is 500, this is 10. Oh, third is 10, yeah, and the fourth is in one-step increments. Okay, so it has found zero order. If it hadn't, it would tell you zero order not found. The next thing we're going to do is just make sure that it knows where the reference is. We're using the carbon line. The wavelength is 193.026. And again, it's not going to find it right at that wavelength. It'll find it somewhere near. So as your intensity gets larger, that's when it's coming out over on top of the peak, and then it's coming back down again. So it told me that the carbon peak is 192.949. So that should correspond to the highest intensity that we have over here, which basically is right in between these two. So it found the reference line. So that's all we need to do on this screen. Over here is where you set your reference. It allows you to pick whatever you want to use as a reference. But again, that always has to be in the plasma because it's whatever, if you do a peak search or a calibration or an analysis, it's always going to go back and look at the reference, which is this carbon line. So we're not going to change that. If you need to change it for some reason, say you're running a matrix and it has, if it's an organic matrix, it's going to have more carbon in it than an aqueous. Or if you're running, yeah, basically that's the only reason you would change it. You would either change the reference wavelength if it's presenting an interference in this area, or if it's causing a high background because of your matrix. So you could change it to another element. Again, it would have to be either argon. There's an argon line at 404. Right here, that's the most common one. Or if you were purging with nitrogen, you could use the 174 line. Right there, 211. Other parameters, if your reference is overranging, you can reduce the high voltage right here. Again, this is the voltage that's on the photomultiplier tube, and that reduces its sensitivity. This will show you the size of the window that it's scanning for that carbon peak. If it doesn't find it in a small, it goes to a large and looks for it there. Integration time, you can leave that at 0.2. Yeah.
I have a quick question.
Yeah.
How do you know when to adjust what the parameters are for adjusting the voltage? How do you know to push it to like increase it by 50 or 100 or?
If it says reference failed, it might be finding the peak, but it might be so small that it doesn't distinguish that it's a peak. So the first thing you could do is increase the voltage to bring it up. It's going to bring the background up too, but it might bring it up enough where I think one parameter is that the peak has to be 3 times the background intensity in order for it to say, yeah, this is a good peak.
I see. So just trial and error kind of.
Yeah. And if, like I said, if you have a matrix that has a lot of carbon, then you would want to reduce the voltage because it's going to overrange that carbon peak, or you might want to use the argon peak instead.
Thank you.
Mm-hmm. This is configuration. I don't believe you need to go into here for anything. This is just stuff that I set up. Yeah. This is a diagnostic screen. We use it more than you would, but I want to show it to you anyway. What this does is allows you to control the grading and the slits manually. What I'm going to do is put in a standard that we have made. Sorry, I hit that. Get rid of this. There's a cap somewhere. Okay. So that standard has aluminum, lead, cadmium, potassium, magnesium. So I'm going to go manually to a lead peak. So here I choose what element I want. And I'm going to go to the most sensitive lead line. It's 220.353. Click on go. Yes, this is French. Actually, it's Russian. Misspelling. And now the grading has moved to this wavelength, and it's not exactly on top of the peak. I'm going to tell it to move, and it'll find it. And when it does, you'll see that it comes up. As it's scanning, it's going to come up and then come back down as it goes over the peak. Now, it may not be up in wavelength. It might be the other way, but we don't know where it is yet, but it'll find it. All right, so that's coming up on the lead peak, and then it'll go over top of the peak, come back down. If I tell it to go back the other way, it'll go back over the peak again. So then what I'm going to do is I'm going to stop it on top of the peak, and now I'm going to tell it to just look at it without moving. Now could you hit the stop button on that pump? If I stop the sample from going in, it'll go away because there's no more lead going in there. And then if you just hit, I think you just hit stop again, it'll start. Yeah. So if for some reason, I mean, there's a lot of argon lines too. So if for some reason it finds this peak, but it doesn't go away when you stop the pump, then you know you're looking either at argon or carbon or if you have nitrogen going in. Another thing that we can do here is manually change the slits. The entrance slit, I'm going to make that smaller. So if I make it smaller, my signal should drop off, because now it reduced the amount of light coming into the box. If I make the exit slit larger, it should increase the signal. And then if I make the entrance slit larger, it should increase it even more. So now I know my slits are working. If I want to reduce my high voltage, I just do this, and it'll reduce the signal. If I want to reduce my gain, this is the gain on the amplifier, that'll reduce it more too. I can increase my acquisition time here, and that it'll increase it. Well, now it just. So anyway, just some stuff. Each one of these steps is 2 picometers. Bing, bing, bing. This is your intensity. This is your 1 second intensity. Just something you might want to use. Who knows? What else? Okay, you don't have a poly. This is just a flow chart, a troubleshooting flow chart. It's we're not online, are we? We are? I didn't think it was. No, it doesn't have to go online. So it's just a flow chart of different problems that you might have. Who knows? Auto sampler you don't have. This is just depending on how much information you want to print, you could tell it how much information of each one of the tasks. This, I think, is just sounds for different things that it does. I don't know what that is. I'm not sure what that is. I'm not sure what this is either. It's a chart, but I've never used it, so I can't explain it to you. I guess if I can't explain it to you, you have no use for it. These are your results, but we're not going to go there yet. So what we're going to do first is make a method. I hope. Hello. Okay. So if we want to use a method that's here, we just click on open. It'll tell you how many methods you have and which one you want to use. So for now, let's say we're going to make a new one. So I'm going to say new. And name it whatever I want. It's always ICP. And here you could either choose elements from another matrix, from standard, from another method. I'm going to say from base of elements. I'm going to say I want in ppm. Next. Here I choose what elements, so I'll say aluminum and lead. Next. This is just an information table. It's not what your standards are. So I know that aluminum is 5 and lead is 10, so I'll just leave that there. That's just the range. Here you choose what wavelengths you want to use. So I'm going to delete the 309 and I'll leave the 220. And then I want to add a line. So here it'll pull up the most popular aluminum and lead line. So I'll choose the 396, which is what I used. So now we have these two elements, or these two wavelengths in our method. Go to next. And here it will, well, the pump you don't have any control over, so it doesn't matter what this is on. Transfer time is the amount of time it's going to take from your sample to get to the plasma. So if I say 10 seconds, it's going to wait 10 seconds. Rinse time is only used, well, again, you can do it manually, but this is mainly for an auto sampler, so when it leaves the sample, it'll go to a rinse position and back to the sample again. This is useless because all of these controls are manually on the front, so you don't have any software control of the plasma. Analysis mode is usually normal. If you want to use standard addition or make everything 100%, you could choose one of those, but I'll just use normal for now. Here's where I add my standards, so I'm going to say add, manually, ppm. Both of these are in my standard, so I'll leave them, and then I'll say, I'm going to call it standard low, and here I'm going to put the concentration, which is 0, so that's done. And then I'm going to add another standard, and I'll call this standard high. And I know my aluminum is 5 and my lead is 10. And that's all I'm going to do is just a blank and a high. Then what I do is I want to tell it how I want to analyze those lines. So I'm going to go to lines, have to be in edit, highlight both of those, modify, acquisition. So there's a couple different ways to do your acquisition. What I usually do is Gaussian, curve, asymmetrical slits, entrance is large, exit is small. My integration, it's going to do 9 measurement points, and it's going to calculate the concentration on 5 of those 9. The acquisition time will be ½ a second per point. My increment will be 2 picometers per point, and I'm going to use Gaussian. Again, you don't have any gas control, but here is you can set the voltage and the gain manually, but what you normally do is something we call an auto attenuate, and it'll automatically set the voltage and gain for that concentration of that element. I'll show you how we do that. So I'm going to leave this as customized and just click apply to all, and I'll say yes. Now, as you go up in wavelength, the peaks will get broader, so I may want to increase the steps for my aluminum peak to say 4 picometers per step, because otherwise it'll be very wide when it analyzes. So if the increments are larger, then the peak will be more defined. Peak search we don't have to bother with. When it does a peak search, it will go to the theoretical position and start scanning and look for that wavelength. If it doesn't find it, it goes to a larger window. And here you can set your window sizes under peak search. Profile, I'll show you later how we're going to do that. So now I'm okay. I'm going to save all that and close it out. Next thing I'm going to do is I'm going to take that method and I'm going to put it to use. So this is my tasks and sequences. So the sequence is what the instrument's actually going to do. So here's where you pull up the method, and then I'm going to say new sequence. What I'm going to do first is a peak search. So that's my first thing. And here I click on, and it'll ask me if I want to do it on both elements. I'm going to say yes. Then I'm going to do an auto attenuate. The auto attenuate will then go to the top of where it found the peak and start adjusting the voltage and gain for the best setting that it thinks it should use every time it goes to that wavelength. And that's always done on your high standard. If you have 5 standards, you do it on the highest one of those 5. And then we're going to do a calibration. So because I'm going to do my peak search and auto attenuate on my high standard, I'm going to rename this STD high, and also the peak search will be the same. And I'll just save this as, I always call it the same as the method. Okay, so we're still in the standard over there, right? Okay, so then I'm going to hit go. Okay, this just... So because I put a rinse time in, it's asking me to do the rinse, but I don't care about that. So now the first thing it'll do is look for the reference wavelength, which is that carbon line at 193. Well, first there's that 10-second transfer time, but normally I don't put one in because I do everything manually, and you know yourself when it's in the plasma. So right now it's looking for the reference. It's moving to that carbon line, and then it's going to start the acquisition. Once it finds the reference, then it'll go to the first wavelength in our sequence. For some reason, it's not doing anything. Okay. I don't know why it's stuck. Let me just see what we're doing here. Final rinse. Okay, we lost the reference for some reason. So now I'm going to stop it and go back and do a zero order. I don't know why it lost the reference. Maybe when I was in diagnostic it got confused. Huh, that's weird. Volts. Lost the reference now. The plasma's lit, right? That's weird. Lost the reference. Why did it lose the reference? I don't know. It lost the reference now. I don't know why. It was working fine. Didn't touch anything in here. Please stand by.
We're going to commercials now?
And now a message from our sponsor.
Yellow?
But not that big.
Yeah, we'll cut it. It's easier to just leave running. No worries. I want that. It's like ours. Post it on Facebook.
He's sucking up the standard. There's a little bit left. You want to put it back in this one, or?
It's okay, you can hang on to that.
All right.
Because you're gonna use that model, right?
Yeah, I hope it finds the reference so we can continue here. I don't know why it lost it. So slow. I don't know what happened. Now it's not finding the reference. Damn. it ended up shifting. I don't know why, but what I did parameters, and I made the initial window larger. So instead of it being 0.05, I made it 0.2, and it found it. So then once it found where it was, I came back and made the window smaller again, and now it's finding it. So I'm going to restart the sequence and see if it's going to be happy doing that. This should be the lead wavelength that it's looking for. That looks kind of small. There's something weird going on. Now, so what it did first was a peak search in a small window, didn't find the peak for aluminum, so it went to a larger window. Now that it found the peaks, it's doing the auto attenuate. So what it'll do is it's going to scan, but at the top of the peak, it's going to start adjusting the voltage and the gain. So it's optimizing the photomultiplier for that concentration of that element. So now I'm calibrating the high. I'm going to do 3 replicates on each standard. And if you want to see the intensities, they're on this tab. So here you can see what your RSD come out to be according to the 3 measurements. So anything below 1.5 is good, so that's pretty good. That's a little high. So let me put it in the blank, do that. Didn't Laura said you had to leave it too?
Yeah.
Huh?
She already left.
Oh, she did?
Yeah.
Oh, okay. So here it should just be a flat line, since there shouldn't be any lead or aluminum in there. Oh. Let's have that checked. Okay, so here we can click to see what our calibration curve looks like. And here it'll tell us the detection limit. Well, it'll tell us what the intercept is. So, and then what it'll also do is puts that back into the method. If we go to the method, and go in calibration, it'll put the curve in there too. So then whenever you do an analysis, it'll look at your curve and, compare those intensities and tell you what the concentration is. Did she make more standard or no?
Yes.
Oh, she did. Okay. All right. Just okay. Let's choose this. I'm just redoing I should put a profile in there too. This is weird. If for some reason it doesn't find a peak, like here, it didn't find my cadmium peak, so that's why you got the red circle. If I tell it to look this way further, I just double click on here, and then it'll ask me if I want to resume, but I don't want to resume, I want to look for it again. So I'll edit it and then just tell it I want to search cadmium. Yeah, because I didn't find the cadmium peak for some reason.
So by double clicking on it, shifted where you wanted to look.
Right, you're telling it you want to look over there. It could be either way. I don't know. I don't know why. I mean, it was working fine when I did it earlier. So it's over all the way on the left now. So when it goes to a larger window, it'll find it. So what I'm doing, what I added to this sequence is a profile, and what that does is it records the peak search graph and it keeps it in your method. And what you can do with that is add background correction, which will subtract the background from each one of the calibrations and analysis. If you have a high background, you don't want that intensity in there. So now that I've done the profile, if I go back to the method, and I'm going to go to modify all the lines, and then go to background. I select the profile that I just did, which is this one. So now it'll bring up all the 4 elements that I just searched. So if you wanted to subtract the background from your analysis, you can just double click here and it'll put a number in, this many picometers before the peak on the left side. So then every time it does an analysis, it'll subtract this intensity from your peak intensity to give you the true intensity. That's if you have a high background, or if you have a sloping background, then you want to put a background point on each side of your peak. If the background's the same, you just need one. So, and then your results should end up here. So I didn't do any analysis, but my calibration is here, I believe. So, and you can choose different, whatever format you want to put your data in. You have a bunch of different ones here. And let's see, where exporting is. Exporting is in the method. Right here. If you want to do a text or an Excel, you can choose it here in the method under information, or result parameters, sorry. So that's pretty much it. Does anybody want to try, make a method of their own and try it, or?
Okay. So what are we trying to do? Are we trying a new sample?
Yeah, you're gonna make a method first. I'll walk you through it.
Okay, great.
So you're gonna go to your method here.
Right on the left.
Oh, that's why it was over there.
Okay.
And then new. And call it whatever you want to call it.
Oh, method. Okay.
Yeah, method name. Go put this back in the rinse.
Next.
Yep. And just choose from elements now, so you can select what your concentration.
APM, right?
Yeah, whatever. I mean, you could use micrograms per liter, whatever. You know, that's up to you what unit you want to use. And there you choose what elements you want to use.
So are we going to use the same elements?
Yeah, if you want to use, because we only have that one standard made up so far.
Aluminum and?
Lead, potassium, and mag. That's what's in there. Lead, cadmium, aluminum, magnesium.
What's that? And potassium.
Potassium, yeah. Now that's just a range. It's not your standard, so you can leave that alone. What it does is in the analysis, it'll just make that box red if it's out of that range. And there you choose what wavelengths you want to analyze on those elements. You could either delete or add lines there if you want.
This is like the standard, so we're supposed to be looking at, right from the library.
Right, like the potassium line, that's the most sensitive one. The potassium doesn't have very many. And lead, that's the most sensitive lead line. The cadmium line we use is 226 for checking it. So if you want,
Add line?
you can delete first. Yeah, and then just check cadmium off. And then go to add. And then you add the 226 cadmium.
Gotcha.
And now that's in there. So now next, yeah, next. And like I said, you don't have, if you want to rinse time, you know, if you're going to rinse it, because you're going to do everything manually anyway, so that's, you can take all that out, really.
Zero?
You have no pump control, so that don't matter.
Transfer to 10, we're going to keep it 10 seconds?
Yeah, you can, if you want, you can keep it 10 seconds. This way, once you put it in the sample, it'll know it's going to wait 10 seconds and then start whatever it's going to do. Yeah, that's about it. And there you can make your standards. So you click on add. Next.
Standard?
No, manually, yep. And then, now, if those elements aren't in, say you have two standards, one only has potassium and the other has those, you can deselect, you know, which ones you want. But if those three elements are in all your standards, you can then just go to next and name the standard over on the left.
So, what is the concentration? For the standard?
The low is 0, so you can leave that. And then you can rename the standard whatever you want. If you want to call it blank or...
Oh, this is just for low?
yeah, that's just the low.
Okay.
right? And now then you're gonna put in your high standard.
What is this high standard?
Now click on finish.
Finish? Oh.
Yep, and then add again.
Oh, gotcha.
And now you put in, yeah, next and next.
Ah.
And now, yeah, now you
Very
put,
clear.
no, just, you don't, I don't know why the standard deviation has a field to change, but I don't know why. So there you put the concentration. Potassium's 15, cadmium is 1, and lead is 10.
Finish.
Right.
So you have to get the high and low range.
Yeah, I thought it was like,
yeah.
it was one, it's like
Yeah, okay.
low and high. in the
No,
same column.
yeah,
Gotcha. Then finish.
right. Okay, then go to lines, line tab on the left, right? And then go to edit on your right. And then highlight all 3 of those. And then click on modify. And go to acquisition. And you can just click on customize. It'll just do a Gaussian fit for all of them. The other analysis mode is max, which is, it goes to the very top of the peak and it sits there for a longer time. But you can just hit apply to all. And just, yeah, right, that one. And then okay. And then just click save over on the right, and you're done. Close that out. And then go to tasks and sequence. Yep, right there. And then you can call the method up here, the one you just made, and then click on new. Now the first thing you want to do is a peak search, which is this. Then you want to do an auto attenuate, and then you'll do your calibration. And then after that, you can click on analysis, and then you can analyze the standard too. So just click save as, you name it whatever you want. And then just click on that, and just make sure you're in the standard.
That's what the 10 seconds are for.
Yes.
Just run to the sample.
Yeah. Okay, it should be in there, and then just click on that. Click close. Yep. And then it hopefully will find the reference and be happy.
So when we did the setting the limits, we had to choose what was in our standard both times. So you could theoretically use 2 different standards.
Oh, you can use.
You can use as many as you.
Oh, yeah.
As many different samples as you want.
Yeah, if you're measuring percentage and trace,
Yeah.
you can use 5 different standards and have one, like say 50 ppm, and have your lowest at like 5 ppm.
So
So this way it covers a broader
oh,
range.
Is that what the time then is for? So for you to switch from standard to
Right.
standard?
Well, I mean that'll prompt you anyway.
Okay. Yeah, because so manually it'll prompt us when to go.
Right.
Okay.
If you name each sample a different name, then it'll prompt you for that particular sample. Like where it said sample name.
Yeah.
If
Okay.
the samples are named the same, it'll just keep going without stopping.
Okay.
Okay, I'm just gonna keep it going there. So because we're gonna auto attenuate on the same standard, we don't have to change anything. We could have given that the same name, and it would have just kept on going without a prompt. Okay, now you have your blank first or your, what's that? What'd you call that?
Calibration standard. So the standard again. Whatever you want.
Let me just signature up. So that's your high then, right?
Yeah.
Okay, so you can just keep going then. Well, if it's backwards, we'll know it. The curve will look, it'll go this way.
So this is the only for the first part for the calibration, and then when is becomes the part when we have our sample?
Right after the calibration. See the
When you
last.
say analysis.
Mhm.
That's out. That's the.
So what we're going to do is after we calibrate, we're going to analyze the high standard.
Oh, gotcha.
So it should come out to what the values, you
It
know.
should be the same
yeah,
thing.
hopefully. That would always be a good thing. Okay, so now we'll do the blank. Actually, you know what? There's some DI water in
Yeah.
one of the, because this is kind of low. I think there's enough in there to do it. It's this one. Yeah. Okay. So if you click on the prompt, it should start calibrating the blank then.
We're gonna have to. What is the limit for the tank here? 200 psi.
I'm not sure. I mean, we're at 90, but
Yeah.
I was telling
Laura.
one of the doctors, no, I
Oh,
said if
Sasha.
you, this will last a full day if the plasma's on all day. Because he was wondering whether to get a doer or bottles. I said, if you get a doer, it'll last you a week if it's on all day.
Yeah,
but
but
then-
we can turn it off, right? I mean, when
Yeah,
this
but
is over, we
oh
just-
yeah, yeah, you can turn that off.
Okay.
All right, let's see what the calibration curve looks like. Yeah, it's backwards.
Goes backwards.
Yeah, see? All right, so we'll have to. So I'm just going to reverse these two. Actually, we're in a blank right now, right? All right, so I'll just keep
Yeah.
it the same. And get rid of this. Ah, that's not what I wanted to get rid of. And we said this was the blank, right? I hope I
No.
don't have it mixed
Yeah,
up.
that was the blank.
Okay. All right, so let's redo that.
So we're gonna do we're gonna do that as much as like we're gonna do the standards as much as standards that we have. I mean the different type of elements that we want to analyze.
Right,
High and low.
right. Unless, like I said, unless you want a wide range, then you'll have to add more standards. Different concentrations of those elements.
Yeah, because of what we're looking for it was like they have like this, like 3 different elements in one standard.
Mhm.
There's another standard with the other 3 different. So can we just ignore the ones that I don't want to analyze?
Sure.
For
When
example, you have 3, but I just want to analyze 2. Can I just put 2 here?
you can. The way you do it is
and
when you're making the sequence, you'll click on the icon.
Yeah.
You have to be in edit. You click on the icon, and there it'll give you a choice of deselecting whatever you don't want to.
Okay.
Yeah.
Yeah, because sometimes like you have 4 different elements, but I just want 2 of those.
Yeah, yeah, and you can calibrate all 4 if you want. And then when you do the analysis, you can if you only want to analyze 2. Say that sample only, it doesn't have
Yeah.
2 of the 4. Yeah. All right. This one. I'm gonna go to the bathroom. When
Okay.
that's done,
You
it's
just-
in
I
your
keep-
high.
Yeah.
So, but just check the calibration curve first. Make sure we did that
Okay.
right. Just click on the calibration icon, and it'll bring up the curve. So as long as it's sloping the right way, then you can analyze that standard.
It was correct.
Okay.
It was fine.
So if we want to look at the intensities while it's doing that, you can just go to here. And it should be close to the standard. It's reading 1004, so. And then that won't keep going, so you have to.
Oh, it gives you the concentration. Okay.
Right. Yeah, in analysis, it'll give you the concentration. So cadmium should be 1.
It's 1.5.
No, it's 1005. This is the RSD.
Oh.
And then cadmium should be 1. So your calibration did come out good.
So the calibration, the unknown is equal to the calibration. That's fine. We're doing a good job.
And the potassium is 15. Wow, that is good. You guys got a good machine. Instrument, sorry. They used to give me hell for saying machine when I first started with the company. It's not a machine. It's an instrument. All right, so, and then if you want to look at results, you just go to, close that out, go here, unknown. I don't know what all these are, but
And it pops up a PDF file?
no, won't do PDF.
Okay.
So here's your 3 reps of each one. It gives you other stuff too, but like I said, it doesn't know that because you don't have any plasma control.
So the last 2 columns were the results, right?
Let me just see what this is. Yeah, 1005. Well, this doesn't give you the replicates. They just
Okay.
give you the average.
No, that's fine.
Yeah. Now I put the user manuals on the desktop
Okay.
right here. Another thing I forgot was if there's any lockup problems with the database, there's a DB repair tool. I'll just put it on the desktop. Where are we? Program files. Bin. DB repair.
Oh.
So I'm going to send that there. So let's have that. It's always 5.2. And then what you would do is click on verify. It's going to go through the database and see if it finds any errors. Sometimes it doesn't work. I mean, but for a database problem, and these should all come up true. If you have a false, just click on repair and it'll do something.
great.
So, excuse me. Hey, Sherry. Okay, I'll be down tomorrow morning then. Okay, see you then. Bye.
When I lose power in my lab, all my computers shut down and log off. So, but I guess I should just ask you. So I don't know what our plan on to run this is. Whether or not we're going to keep it on overnight for the course of a week and just run samples for a week and then shut it down. But I know in my lab when I have equipment on when I'm connected to the network, the network will update my computer and then it will shut it off and it will log me out. So when that happens, when the computer, like we lose power and the computer shuts down, is there a specific order that you have to make the connection from the instrument to the computer, or
No, you just have to.
one doesn't have to be on before the other, or
Oh, no,
a
no.
series of okay.
Actually, this should be on before the computer.
Okay.
Yeah,
I
yeah.
was just curious because that happens every week and
Okay.
it's a pain to it's actually
So we good? Anything else?
So, okay. So you got that when we have to.
Yeah.
So we can turn it off, right? Now.
Mm-hmm.
We'll just close everything and that's it.
Yep.